Good morning, class. Today I'll discuss the computer number system. But before that, let me discuss the continuation of our video lesson last time. And these are spreadsheet and view button. First, what is spreadsheet? A spreadsheet is a software that permits numerical data to be used and to perform automatic calculation on numbers contained in a table. Spreadsheets are made up of columns, rows, and their intersections are called cell. Excel is a spreadsheet, a grid made from columns and rows. It is a software program that can make number manipulation easy and somewhat painless. Lastly is view button. In Microsoft Office programs, such as Excel, PowerPoint, and Word, the view buttons are a feature that lets you change how the presentation or document appears. Let's proceed to our main topic for today. What is computer number system? Humans use words and characters to communicate and are familiar with working with numbers, letters, and words. However, computers cannot process this type of data directly, they can only interpret numerical values. Computers understand numbers differently from humans, necessitating the need for an entirely other system. Every time we enter text into a device, the characters are converted into numbers that only the computer can comprehend. Let's proceed to the types of number system supported by computers. In computers, there are primarily 4 types of number systems. We have decimal, binary, octal, and hexadecimal number system. First, let me discuss the binary number system. The binary number system, also known as the base 2 system, is a numeral system that uses only 2 digits, 0 and 1. The base is 2 and digits are only 0 and 1. In binary, each digit is called a bit, short for binary digit. Next is the decimal number system. Also known as the base 10 system, is the numeral system most commonly used by humans for everyday counting and calculations. It uses 10 distinct digits, 0 through 9. This system is based on powers of 10, which reflects the human tendency to use groups of 10 in counting. The base is 10 and the digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Next is the octal number system. Also known as the base 8 system, uses 8 distinct digits, 0 through 7. Base is 8 and the digits are 0, 1, 2, 3, 4, 5, 6, 7. Lastly, the hexadecimal number system, also known as base 16 system, uses 16 distinct digits to represent values, 0 through 9 and A through F. Base is 16 and the digits and letters are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F. A represents 10. B represents 11. C represents 12. D represents 13. E represents 14. F represents 15. 0 exponent law. A to the raised power of 0 is equal to 1. And identity exponent law is A to the raised power of 1 is equal to A. For example, we change 2 raised to the power of 0 into 1 on the right side sample. And for 2 raised to the power of 1, we change into 2. And for the clarification, any number by multiply in 0 is 0. And now let's start on how we get the octal number for 251 base 10 is equal to blank base 8. Again, base 10 is for decimal and base 8 is for octal. Let's start. 251 divided by 8 is equal to 31. How to get the remainder? Just multiply 31 to 8, so 31 times 8 is equal to 248, then subtract it to 251, so 251 minus 248 is equal to 3. 3 is your remainder. Next, 31 divided by 8 is equal to 3. Then 3 times 8 is equal to 24, then 31 minus 24 is equal 7. Next is 3 divided by 8. You can't divide 3 to 8, that's why your quotient will be 0, then copy 3 for your remainder. You stop if your quotient is 0. Write the answer from bottom to up. Follow the arrow. For 251 base 10 is equal to 373 base 8. Now how to get the decimal number? For checking. So we have 373 base 8. Starting with the rightmost digit, list all of the exponents of 8. The first power would be 8 raised to the power of 0, which is the 3 on the right side, and as we move on to the left side it will be 8 raised to the power of 1 for 7 and 8 raised to the power of 2 for 3 on the left side. So you will multiply 3 times 8 raised to the power of 0. It's 0 exponent law, we change it into 1. So, it should be 1 times 3 is equal to 3. Since we have 8 raised to the power of 1, it's identity exponent law. So it will be 8. So 8 times 7 is equal to 56. Lastly, 8 raised to power of 2, so 8 times 8 is equal to 64. 64 times 3 is equal to 192. The sum is 251 base 10. And now let's start on how we convert the decimal number 1521 base 10 to hexadecimal number. Again, base 10 is for decimal and hexadecimal is base 16. Let's start. 1521 divided by 16 is equal to 95. How to get the remainder? Just multiply 95 to 16, so 95 times 16 is equal 1520, then subtract it to 1521. So 1521 minus 1520 is equal to 1. 1 is your remainder. 95 divided by 16 is equal to 5. How to get the remainder? Just multiply 5 to 16, so 5 times 16 is equal 80, then subtract it to 95. So 95 minus 80 is equal to 15. But you will not write 15, you will write the letter represents number 15. It's letter F. You will write the answer from bottom to up. The answer is 5F1 base 16. We have here 11,100 base 2. Starting with the rightmost digit, list all of the exponents of 2. The first power would be 2 raised to the power of 0, 2 raised to the power of 1, 2 raised to the power of 2, 2 raised to the power of 3, and 2 raised to the power of 4. So let's start. 0 exponent, so it should be 1, so 1 times 0 is equal to 0. Identity exponent, so it should be 2 times 0 is equal to 0. Again, any number by multiply in 0 is 0. 2 raised to the power of 2, it's 2 times 2, so 2 times 2 equals to 4 times 1, it's 4. 2 raised to the power of 3, it's 2 times 2 times 2. It's 8, so 8 times 1 is equal to 8. 2 raised to the power of 4, it's 2 times 2 times 2 times 2. It's 16, so 16 times 1 is equal to 16. The sum is 28 base 10. For decimal to binary. Your remainders are only 0 and 1, if there's a remainder you write 1 and if it's exact number you will write 0 in the remainder. Let's start. In the left side column, write 282 divided by 2 is equal to 141, there is no remainder, that's why I write 0 in the remainder column. Next, I will write 141 divided by 2 is equal to 70, since there's a remainder, I'll write 1 in the remainder, again the digits are 0 and 1 only. Next, 70 divided by 2 is equal to 35, 0 is the remainder. Next, 35 divided by 2 is equal to 17 and 1 is the remainder. 17 divided by 2 is equal to 8, remainder is 1. 8 divided by 2 is equal to 4, remainder 0. 4 divided by 2 is equal to 2, remainder 0. 2 divided by 2 is equal to 1, remainder 0. Last is 1 divided by 2 is equal to 0, remainder 1. That is the last because we get the 0 quotient. So, you will write the answer from bottom to up. 282 base 10 is equivalent to 100, 011010 base 2. Thank you for listening. Tomorrow don't forget to bring your own calculator.